Good morning, children. In the last class, we discussed about finding the sum to n terms of a GP, sum to n terms of a geometric progression. The sum to n terms is given by the formula. What is the formula? Recall it. For the sum, you have two formulas, isn't it? If the common ratio is less than 1, one formula is there. Common ratio is greater than 1 means another formula. Okay, recall the formula. What is the formula we have learned? Sum is given by Sn is equal to A into sum is given by Sn is equal to A into 1 minus R raised to n by 1 minus R if R is less than 1, isn't it? And it is A into R raised to n minus 1 by R minus 1 if R is greater than 1. And at the same time, sum to infinity terms, S to infinity is given by A by 1 minus R if R is less than 1 and A by R minus 1 if the common ratio is greater than 1. This is given about sum to infinity. Now, based on this, let's do a few questions. Write down. Write the question. Find a GP for which you have to find a GP for which sum of first two terms is minus 4. Find a GP for which sum of first two terms is minus 4 and fifth term is and the fifth term is 4 times the third term. Fifth term is 4 times the third term. You have to find the GP. GP means, while you write the GP, general form of GP is, what's the general form of GP? We take the GP as always. Let the GP be AR square, AR cube, and so on. Let the GP be AR square, AR cube, and so on. Now here it is given sum of first two terms is minus 4. So sum of first two terms means A in plus AR is minus 4. A plus AR is minus 4. From here we can take one A outside. So we'll get A into 1 plus R is minus 4. So write this within bracket. Name this as equation 1. Now look at the second point. What is the second point given? Fifth term is 4 times the third term. Fifth term is 4 times the third term. So fifth term means A5 will be same as, how will you write A5? Fifth term. In a GP, the fifth term is given by? Yes. Yes, Naureen. Fifth term is given by? Very good. AR raised to 4 is equal to 4 into Jewel, A3.
AR raised to 2.
AR raised to 2. Okay, so both the sides we can cancel one A. So one R square also will get cancelled. So we get R square is equal to 4. Is it correct? Therefore, what is R? R is plus or minus 2. We get the value of R as 2. Okay, we get the value of R as 2. If R is 2, when R is 2, find out what is A. When R is 2, A into 1 plus 2 is 4, isn't it? From the first equation. So we get A as 4 by 3. A is 4 by 3. So in this case, what is the GP? Therefore, the GP is A, AR, AR square, and so on. So A is 4 by 3. 4 by 3. 4 by 3 into 2. 4 by 3 into 2 square, and so on.
Ma'am,
Yes.
isn't it negative?
Which one?
My 8.
Oh, okay, okay. It is minus 4. Yes, correct. It is minus 4. The question is it given as minus 4, is or not? Yes. Yes. So what is the GP? Therefore, the GP is, in the first case, minus 4 by 3, minus 8 by 3, minus 16 by 3, and so on. Now, in the same way, do the second case. Use the same method. Find out what is the GP in the second case when R is minus 2. When R is... Huh? When R is minus 2, what is the GP? When R is minus 2, find out what is A and what is the GP. Finished? What is the GP, Aditya?
4, 8, 16.
4 by
A is 4.
A is 4. Okay, A is 4. So the GP is 4. Is it GP is What is A? What is the value of A, Aditya? Is it A4? When R is -2, Shabarinath, what is the value of A?
I got 4.
You got 4. So what is the GP, Jewel?
-4.
-4.
-4. No.
A is 4.
4. Then 4 into -2.
4 into -2.
4 into -2 square.
And so on. So it is 4, -8, 16, and so on. Is it correct? Is it okay? Is it correct, Niranjan? Malaviga?
Yes, ma'am.
Okay. Is it okay, children? Here we are finding the GP. GP means you have to write the sequence. A, AR, AR square, and so on. You have to write the sequence. Now write the next question. Next one. If the first term and the nth term of a GP are, if the first term and the nth term, if the first term and the nth term of the GP, first term and the nth term of the GP are A and B, small letter A and B, are A and B, and if capital P is the product of n terms. If P is the product of n terms, then prove that P square is equal to AB whole raised to n. P square is equal to AB whole raised to n. So first term and nth term of the GP are A and B. If P is the product of n terms, prove that P square is equal to AB whole raised to n. P square is A into B whole raised to n. How to do this? So listen, children, sit straight and listen. This one and all, you do it again and again, then only it will become clear. It's a simple question, but the chances of doing mistake is more. Okay, it's a simple question only, but what we'll do, we'll get confused and everything. We're final. Okay, we'll be struggling a lot to prove this question. Okay, now look at here. The first term is given as A. So the first term, we always denote it as small a, isn't it? First term, it is given as A. And the nth term is given as B. What is the nth term? The nth term means AR raised to n minus 1 is given as B, nth term. Is it correct? We want to find, we have to prove that P square is equal to AB raised to n. And what is given about P? P is the product of first n terms, isn't it? It's the product of n terms. So A into AR square. What will be the nth term? Nth term is AR raised to n minus 1. Nth term will be AR raised to n minus 1. Is it okay? Is it clear? B is the product. Product means we have to multiply A into AR square into etc. up to AR raised to n minus 1. Up to that, is it okay, children? Is it okay?
Yes.
Now, A, we are multiplying it. A into. How many times A is there? How many times we have A there? 1, 2, etc. How many times? N times. Okay. Here, if you start from here, n minus 1 along with this means you'll get a raised to n into, if you group the r terms, okay, we know the property. What is a raised to m into a raised to n? It is a raised to m plus n. When we multiply, add the powers. So here when we add the powers, we'll get 1 plus 2 plus 3 plus etc. up to plus n minus 1. Okay. Up to this, is it okay? A raised to n into r raised to 1 plus 2 plus etc. up to n minus 1. What is the sum we have learned? Last year we have learned what is sum of first n natural numbers? What is the sum of first n natural numbers? Yes, 1 plus first n natural numbers means 1 plus 2 plus etc. up to n. If you add up to n, it will be n into n plus 1 by 2. Sum of first n odd natural numbers is n into n plus 1 by 2. But here we add up to n minus 1. So we'll get a raised to n into r raised to. When we add up to n minus 1, we'll get n minus 1 into n by 2. Is it okay? N into n minus 1 by. No. Okay. Now what do you have to prove? We have to prove p square. We want to prove p square is equal to ab whole raised to n. How to prove this? What is b? Look at here. b is a into r raised to n minus 1. Okay, so first let me square it. When you square it, what happens? P square is equal to a raised to n, r raised to n minus 1 into n by 2 whole raised to n. Power to power means what you will do? Multiply, isn't it? So a raised to n whole raised to n. So you will get a raised to n whole raised to n. Is it a raised to n square? R raised to, sorry, it is not n. We are squaring it. So a raised to 2n. We are squaring, not the nth power. We are taking square. So a raised to 2n. R raised to n minus 1 into n by 2 into 2. This 2 will get cancelled. So we will get a raised to 2n. R raised to n minus 1 into n. Now, how will you write this? A raised to 2n can be write like this. A raised to n into a raised to n. R raised to n minus 1 into n. Is it okay? Shall we group like this? Can we split like this? So in the next step, we can rewrite the terms as a raised to n into ar raised to n minus 1 whole raised to n. Is it correct? How? Power to power means multiply the powers. A means a raised to 1. When you multiply it 1 into n, it is n. R raised to n minus 1 into n means we can write this as r raised to n minus 1 whole raised to n. But what is a r raised to n minus 1? Is it b? This b raised to n. So we can combine this and we can write this as ab raised to n. So p square will be ab raised to 10. Listen children, once again I'll explain it. If you find any other easy method, you can give that method. Okay. Any other method, any tricks are there means you can tell me. Now look at here. We are asked to find the product of first n terms. Product of first terms, n terms means a into ar square, etc. up to ar raised to n minus 1. A, we are writing n times. So we know that 2 into 2 into 2 means we can write this as 2 cube. Similarly, here we have a into etc. n times. So we write this as a raised to n. And r raised to, here r is in product. So we can add the powers. When we add the powers, it takes the form 1 plus 2 plus 3 plus etc. up to n minus 1. Sum of first n minus 1 numbers. What is sum of first n minus 1 natural numbers? N minus 1 into n by 2. Up to that, is it okay? This is up to p. Okay. 1 plus 2 plus 3 plus etc. So which is same as a raised to n into r raised to n minus 1 into n by 2. So this is p. So next step, you find out p square. What is p square? A raised to n into r raised to n into n minus 1 by 2 the whole square. Okay, once again, I'll explain this one. Listen. So when it is power to power means multiply the powers. So a raised to 2n, r raised to n into n minus 1 by 2 into 2. 2 will get cancelled. So we'll get a raised to 2n, r raised to n into n minus 1. Next step, we split this. In the final answer, we want b. What is b? A r raised to n minus 1. Okay. So in order to arrange like this, what we do here, a raised to n into a raised to n, r raised to n minus 1 raised to n. Power to power means multiply the powers. Now this one we can write this as a raised to n. Here we are grouping the terms and we write like this. A r raised to n minus 1 whole raised to n, which is same as a raised to n into b raised to n, which is ab whole raised to n. Therefore, p square is ab whole raised to n. Is it okay? Is it clear, children? Sanjana. Sanjana is there. Vinayak. Okay, Sanjana. Jees. Is it clear? Is it okay, Jees?
Yes, ma'am.
Okay. So, children, what you have to do is do this question by yourself. Okay. When we look at when we understand and do it, it is okay. But when we do this question after 1 or 2 days, we'll be struggling with this. I have seen. That is why I tell you. We will not be able to recall how to group the terms. We'll get confused. Here, this question, the last part is important. That's one you have to practice it again and again. Okay, write this question. Any doubt? Any doubt here? Tom, Krishna Kandi? Okay, write this question, children. Atulya. Atulya is present today?
Yes, ma'am.
Okay. Is it okay, Atulya? Any doubt?
Ma'am, after we squared both sides, what do we do?
Yes.
P
Yes.
square equal to, you squared both the sides, right?
Yes. Because in the result, we want square. In the question, we want to prove p square. So when we square it. Okay. Then what is ab the whole square? A square into b square. We split the power. So we can write this as a raised to n whole square, which is same as a raised to 2n. Laws of exponents. Power to power means multiply the powers. Is it okay?
Yes, ma'am.
What about the others?
Yes, ma'am.
Finished?
Yes, ma'am.
John, is it over?
Yes, ma'am.
Okay. The next model we are going to solve is very, 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 very important. Mark it as very important question. Not only for your 11th standard, when you go for any competitive exam, if you write any government PSC exam based on 12th up to 10th level, also this question will be asked. Okay. Yes. Write the question. Find the sum. Find the sum up to first n terms. Find the sum up to first n terms. Under that first one, 5 plus 55 plus 555 plus 5555 plus etc. Find the sum up to first n terms. We are adding the first n terms. That means we want to find Sn. We want to find Sn, isn't it? Sum to first n terms. Y5 plus 55 plus 5555 plus and so on. 5 plus 55 plus. What is the answer? What is the answer? Can we guess? When you look at this question, we'll start off writing like this and we add, isn't it? It is not possible. Actually, if you look at the sequence, is it a AP or GP?
No.
Actually, the given sequence, by looking at it, it is not an GP, isn't it? But we can make it into a GP. We can make it into a GP. Okay, you copied that question? Yes, children, all of you, please turn on your video. It's an important question. All of you turn on your video, sit straight and listen. Keep your pen down, sit straight and listen. Listen, children. The first thing is, okay, instead of 5, although it is coming 6 plus 66 plus whatever it may be, first you take the number outside. What is the number there? You take that number outside. For example, here 5, 55 and so on. So what I'm going to do, I'm going to take 5 as common. So what you will get? 1 plus 11 plus 111 plus 111. Is it okay? The first step, is it okay? The next step, we multiply and divide by 9. Okay, whatever may be the number, if it is instead of 5, if it is coming 7, method is same. Take the 7 outside. Next step, multiply and divide by 9. So dividing by 9, you keep it outside. So with 9, you multiply inside. 9 plus 99 plus 999 plus 9,999 plus etc. Is it okay? Up to this, is it clear? Akshay? What we did, the first step, you take the number outside. Next step, what we did? Multiply and divide by 9. So the multiplication by 9, we take it inside. Division 9, we keep it as common itself. Is it okay? Up to that, is it okay? Now look at the next step. 9. How we can write 9? We want to express everything in terms of powers of 10. We want to write in terms of powers of 10. So 9, how we can write? Is it 10 minus 1? What about 99? 99 is? Yes. 100 minus 1. 10 square minus 1. Next is 1000 minus 1 plus etc. Up to n terms. It is not up to infinity. It is up to n terms. Okay. Up to n terms. Only n terms we consider. So now look at here. This one. We can write this as 5 by 9 into. I'm grouping the tens. Okay. That is 10. 100 means we can write this as 10 square plus 10 cube plus etc. Up to n terms. We get up to 10 terms. Then if you look at minus 1, minus 1, minus 1, minus 1, how many times we will get? Plus n times. So we can write this as plus minus 1 plus minus 1, etc. n times. That is same as, what is minus 1 plus minus 1? When you add minus 1 2 times, what you will get?
Minus 2.
Minus 2, isn't it? So minus 1 plus minus 1, if you add it 3 times, what you will get?
Minus 3.
It is minus 3, isn't it? So same way here, minus 1, if you add it n times, what you will get? We can write this as minus 1 whole, okay, we can write this as minus 1 whole raised to n into n. That is same as minus n. Okay, minus 1. Okay, otherwise you can write this as plus. One more step you write minus 1 plus etc. up to minus 1. How many times? N times. So now if you take the first set, if you look at the first set, this first n terms, is it a GP? 10, 10 square, 10 cube plus etc. up to n terms. Is it a GP?
Yes.
So sum to first n terms of a GP. Apply the formula there. So what is the first term here? First term is 10. What is the common ratio? Common ratio is also 10. If you take the first n terms, so it is 5 by 9 into A is here 10 into common ratio 10 is greater than 1. So you can write this as 10 raised to n minus 1 by 10 minus 1. Is it correct? A into, formula is like this. A into r raised to n minus 1 by r minus 1 plus minus 1, we are adding it n times. So minus n. Minus 1, if you add it 2 times, we can write that as minus 2. Minus 1, if you add it 3 times, we can write it minus 3. Here we are adding negative 1 n times. So it will become minus n. So which is same as 5 by 9 into 10 raised to n minus 1 by 9 minus n. This is our answer. Is it okay? Is it clear? Okay, that is 5 by 9 into 10 raised to n minus 1 by 10 minus 1 is 9 minus n. So this is the sum, Sn. We can stop with this. The sum is given by like this. And Mary, is it okay? Is it clear? And Mary? Pooja?
Yes, ma'am.
Anashwarya, any doubt? Anashwarya?
No, ma'am.
Yes, children. Is it okay? John Philip, John Jos?
Yes, ma'am.
Yes, ma'am.
Renil, where is Renil? Renil, any doubt?
No, ma'am.
Okay. So one more. Okay. Whatever may be the number, the method is same. Take the number outside, multiply and divide by 9. 9, how we can write? 10 minus 1. 99 means 100 minus 1. So we express everything in the powers of 10. And then we will get 1 GP and minus 1 n times. Apply the formula for Sn. Minus 1 when added n times, we will get minus n. And we conclude the sum. Okay. Okay, children, shall I do the next one? Okay. Finish? No. So today I'll be sending 3 questions in this model as assignments, not as homework, assignments. So this is the assignment in sequences and series. 3 questions from geometric progression in this pattern as homework assignment. Do it separate in A4 sheet and keep it separate. Staple it and keep it separate for submission. Okay. Assignment question from this topic. 3 questions. Okay. Okay, write the next question. Write the next one. Find the sum to n terms. Find the sum to n terms. 0.6, 0.66 plus 0.666 plus and so on. 0.6 plus 0.66, 0.666 plus and so on. How to do this? So first take this as Sn. How will you do this if there is decimal? 0.6, 0.66 and so on. How will you do this? Okay, so looking at this, listen children, the method is same. 0.66 means you can write this as 6 by 10. Is it correct? This is 66 by 100. The 666 by 1000 plus and so on. So once you write like this, first you take 6 outside. If you take 6 outside, you'll get 1 by 10 plus 1 by 100. Sorry, 11 by 100. 1 by 1000 plus and so on. Next step, you multiply and divide by 9. So 6 by 9 into, here it will become 9 by 10 plus 99 by 100 plus 999 by 1000 plus and so on. Up to this, is it okay? Is it clear up to this? 6 means you are writing 6. 0.6 means 6 by 10. 0.66 means 66 by 100 and so on. Take 6 outside. So we get 1 by 10 plus 11 by 100 plus 111 by 1000 and so on. Next step, you multiply and divide by 9. Now look at the next step. The next step is important. 6 by 9 into 9 by 10. Is it possible to write 1 minus 1 by 10? Is it correct?
Yes, ma'am.
How will you write 99 by 100? 1 minus 1 by 100. If you want to take the LCM, group it and check 100 minus 1. Is it 99? Plus, similarly, the next one is 1 minus 1 by 1000. Plus and so on up to n terms. Okay, up to n terms. So now group this 6 by 9 into 1, 1, 1. How many times? 1 plus 1 etc. up to n times. And the remaining terms, if you group minus 1 by 10, minus 1 by 100, minus 1 by 1000, plus and so on up to n times. So it is same as 6 by 9 into 1, 1, 1 n times. If you add, it is n minus. From here, if you take minus outside, it will be 1 by 10 plus 1 by 10 square plus 1 by 10 cube plus and so on. So now look at here. Is it a GP? Look at the second set of terms. Is it a GP? With the first term 1 by 10, common ratio is also 1 by 10, which is less than 1. First term is also 1 by 10. Common ratio is also 1 by 10. So we get 6 by 9 into n minus a. A is 1 by 10 into 1 minus r raised to n by 1 by r. Is it okay? If the common ratio is less than 1, sum is given by 1 minus r raised to n by 1 minus r. A is here 1 by 10. Common ratio is also 1 by 10. 1 by 10 means it is less than 1. So next step on simplifying, we can write this as 2 by 3 into n minus 1 by 10 into 1 minus 1 by 10 raised to n by, here if you take the LCM, 10 minus 1 by 10. Here this 10 will get cancelled. So we can write this as 2 by 3 into n minus 1 minus 1 by 10 raised to n by 9. Is it okay? Is the method clear? Vinay? Anaka?
Yes, ma'am.
Okay. Write this one, children. In the next period, we will be learning about how to find the geometric mean. Okay, how to find the geometric mean. So with this, we conclude the session now. Thank you.